How does the AC work? So today let's look at the technology of an air conditioner. How does it work and its scientific background? So what is the basic duty of an air conditioner? Basically, an air conditioner is cooling down a particular space. That means removing the heat from a space. So how does this phenomenon happens? Normally, you might have seen there are two major components in an air conditioning system. Those are indoor unit and outdoor unit. The indoor unit is installed in the space which has to be cooled, and outdoor unit is installed outside. Normally, it is exposed to the atmosphere. In this case, the heat absorbed by the indoor unit is released to the outside environment through the outdoor unit. To transport this heat energy, we need a media. This media is called the refrigerant. Some people call this refrigerant as AC gas. In the normal environment, heat flows from high temperature body to low temperature body. But in this phenomenon, heat travels from low temperature place to high temperature place. Let's look at the scientific background. Air conditioning mechanism is a cycle, usually referred as vapor compression cycle. There are four major components: evaporator, compressor, condenser, and expansion valve. The refrigerant moves through this cycle. The evaporator is installed inside the indoor unit. Low pressure liquid state refrigerant comes to the evaporator. In this moment, the temperature of the refrigerant is lower than the temperature of the space. Same time, an airflow is blown through the evaporator. As the temperature of the liquid state refrigerant is low, it absorbs heat from the airflow and transfers to gas state. As the heat is removed from the air, airflow gets cooled down. After that, refrigerant which became a gas goes to the compressor. The compressor converts the low pressure gas state refrigerant into a high pressure gas. According to the Charles law, volume of a given amount of gas is directly proportional to its temperature when the pressure is held constant. According to the Boyle's law, pressure of the gas and the volume are inversely proportional when the temperature is kept constant. When we combined these two combinations, gas pressure is directly proportional to the temperature when the volume is constant. According to the Charles law and Boyle's law, as the pressure of the refrigerant gas which comes out from the compressor is high, the temperature also gets a higher value. Normally, this temperature is higher than the atmospheric temperature. This temperature is between 50 to 60 Celsius. This value depends on the environment conditions and the design of the air conditioning system. Then the refrigerant comes to the condenser. The condenser cools down the refrigerant and converts it into gas state to liquid state. All three, compressor, condenser, and expansion valve, are installed inside the outdoor unit. The fan inside the outdoor unit blows airflow through the condenser to absorb the heat from the refrigerant and release to the environment. Thus, the heat absorbed by the evaporator is removed out from the system by the condenser. Then the high pressure liquid state refrigerant goes to the expansion valve. The expansion valve reduces the pressure of the refrigerant. As we discussed previously, according to the Charles and Boyle's law, when the pressure is reduced, the temperature is also reduced. So the low temperature and low pressure refrigerant goes to the evaporator from the expansion valve. Thus, this cyclic procedure continues when the air conditioning machine is working. For the continuous operation of this refrigerant cycle, the energy is supplied by the compressor. Now you might have a question whether the heat absorbed by the evaporator is equal to the heat released by the condenser. No, actually more energy is released by the condenser. The energy is supplied to this system by evaporator as heat, and compressor supplies the rest of the energy by compressing the refrigerant which is in gas state. Therefore, energy released to the environment by the condenser equals to the sum of the energy absorbed by the evaporator and the energy supplied by the compressor. So, stay tuned with us. Please comment your valuable ideas in the comment section. See you in the next video.